Just making sure that the audio is working. It looks like it is. Perfect. So, okay, what are we looking at today? We are not looking at this, we're already at example 2. We're looking at permutations and combinations and really kind of identifying what are the differences between the two of them. And so in order for us to do that, we need to get a kind of understanding out of this first. Okay, and so the first thing we really want to understand is that a permutation has order as its an importance. Okay, so basically meaning that we need to make sure that we have the correct order for something to make sense as a permutation. Okay, so order is important. Okay, you're gonna ignore that, get your notes out. You should already have your notes out. But that is what a permutation is going to be implying here. A order does in fact matter. Okay, and so here's example 1. It says 10 horses are running in a race. How many different ways can the horses finish first, second, and third? Okay, well, in this problem, the first thing we have to really establish is that a lot of us, I know for sure, haven't really seen this kind of problem before. And so in order to help us, we need to look at our reference sheet. Okay, so if you look at the backside of your reference sheets and you go to the section of probability, bottom left, you see the word permutation. That's what we're working with. And so in permutation, you need two things. You need an N, you need an R. Well, N is the number of objects, we'll just call it number of objects. And then the R is typically going to be for order for our permutations. Okay, we'll see that in a little bit. So we need an N, we need an R. And so we're going to reread this problem. We have 10 horses running a race. Well, that sounds like my N, my number of objects. So number of objects. To me, nope, not safe. Give me 10. And how many different ways can the horses finish first, second, and third? So this is our order. And as such, we have ordering 3 different things. So if we were to look at our reference sheet, it shows us this permutation as a P, comma N, sorry, P parentheses N, comma R, like so. Excuse me. Which is actually really not the notation that we're familiar with as far as the math world goes. At least the way I've seen it a lot is going to be more sort of looking like this, where NPR is how I would read that. But realize that their notation is different, but it means the same thing. And so now that we are given this N and this R, what we're going to do is we're going to replace those, right? We said we have 10 objects, so 10, right? P does in fact stand for permutations, so in case you're confused on that, permutations. And then R, which is our order of 3. Okay. Now I imagine a lot of us haven't seen this notation before, and in fact we haven't seen a lot of this stuff that we're about to cover before, but we're going to go with it. If you look back at the equation on your reference sheet, it shows an exclamation mark. And in fact, if we were to replace all these variables, we have 10 exclamation mark, parentheses 10 minus 3 exclamation mark. Okay. Well, here's where we have to address one thing. Okay. This exclamation mark is called the factorial. Okay. And in the factorial, what it does, it takes a whole number, so 10, 3, 17, so on and so forth. It takes a whole number and it multiplies each number going downwards to 0, except not including 0. So really it goes all the way down to 1. So for instance, if we looked at 3 factorial, that's going to be 3 times 2 times 1, and it stops right there. And this is going to equal 6. Okay. Now in class, what I had discussed was that there's 2 ways to really solve this. One is you can solve it brute force, or 2, you can solve it using your calculator. But I want you to understand how to solve it with the brute force way to do it, before using your calculator so that you can understand where everything's coming from. So looking at this problem here, I'm going to show you what you should not do. Okay, something you should not do. So whenever you get this equation, 10 factorial over 10 minus 3 factorial, you can reduce that down a little bit. You get 10 factorial over 7 factorial. And, you know, I think a lot of us would see, oh, we have an exclamation mark at the top and we have an exclamation mark on the bottom. Therefore, we must be able to simplify it. And we get 7 under 10 like this, or 10 sevenths. And I'm telling you, this does not work. Okay, this is not going to work. This doesn't even make any sense in the context of the problem. How can we get 7/10 of the amount of ways to get first, second, and third place? That doesn't even make any sense. So that's out of the picture. It doesn't make any sense. What also doesn't make any sense is saying, oh, well, if I have 10 factorial over 7 factorial, subtract them, we get 3 factorial. This is not going to make sense. Right? We already showed beforehand that 3 factorial is equal to 6. And 10 factorial over 7 factorial, you'll see in a little bit, does not equal 6. Okay, so there are some common pitfalls I can see right there. So do not get that confused. However, if we were to do this the brute force way, we're going to take this 10 factorial, multiply it all the way out, right? Just like how we did with that 3 factorial, and do the same thing with the 7 factorial. So 10 factorial over 7 factorial is equal to 10 times 9 times 8, 7 times 6 times 5 times 4 times 3 times 2, then times 1. Same thing for our 7. 7 times 6 times 5 times 4 times 3 times 2 and times 1. So. And so if this is what we get out of this factorial, what we end up with on the numerator side is we get 3,628,800 on the top, and on the bottom, 5,040. Very underwhelming, it would seem, in comparison. But what we'll find out is that this is going to equal a very nice whole number of 720. And in fact, any combination or permutation question that you'll see is always going to end up as a whole number, never as a fraction, never as a decimal. Okay, so you can always expect a whole number out of this, but you cannot expect a decimal or a fraction out of this. And 720 is our answer. Okay. Now, there are a couple different ways that we could have actually really approached this problem. I'm going to show you 2 ways. One way is what I'll call the pre-college way. And the pre-college way is identifying that, well, if I look back at this whole equation right here, this whole thing, recognize that I have 7s, 6s, 5s, 4s, 3s, 2s, and 1s in common with my numerator and the denominator, and it's multiplication. Because it's all multiplication on top of multiplication, I can cancel some of these things out. So 7s cancel, 6 cancel, 5, 4, 3, 2, and 1 will cancel. And so what we're ending up with, like after we have canceled everything, is 10 factorial over 7 factorial equals 10 times 9 times 8, which, would you look at that, equals 720. And this, again, is what I call the pre-college way. And the next way is going to be more of the college way. College way. And so the way that we're going to address this problem is we're going to say, well, this is the college way. We'll still start off with that 10 factorial over 7 factorial. And you've already understood that the factorial is going to multiply all the numbers under it. Well, if we take that same idea and apply it to the pre-college way, and we see that 7 factorial is 7, 6, 5, 4, 3, 2, 1, all multiplied together. And what we should really see is that there's also a 7 factorial in 10 factorial. But it's slightly different. Where in this case, we're going to have 10 times 9 times 8 times 7 factorial over 7 factorial. Okay, notice again, the numbers that we crossed off each time, that was part of our 7 factorial. And so now I have multiplication times our 7 factorial over our other 7 factorial, and they're the exact same factorial. Now we can cancel it out, none like what we did beforehand with that 3 factorial right here. Okay, that, what I just marked, is not correct. However, this marking off is correct. And what we're left with is 10 times 9 times 8, which again is 720. Okay. Now again, this is the brute force way. Okay. There is a way for us to figure this out on our own. Well, not on our own, but using the calculator. It's going to be a lot simpler for us, a lot easier for us. So the way that we're going to do it is I'm going to show you how to do it on the next problem. So the next problem, what you're going to do is you're first going to annotate. You need to annotate for this because if you, there's a lot of word problems here. If you don't know what the word is telling you, you can't really solve this problem. But again, we need two things. We need our n, we need our r. And so the n is the number of objects, r is the order. And so I have 8 people who serve on a committee. That's our number of objects. So 8 objects we're going to write. And how many different ways can a chairperson, a recorder, and a treasurer be chosen from the committee members? That's going to be our set order. And it's going to be ordered with 3 different options. So we have the thing about like the previous example where we have a first, second, and third place. And so, because this is what we're working with, we know we're working with a permutation because there's a set order to things. So we have NPR. In this case, 8 is my N, P is just P, R is 3. And again, if we were to put it into the notation that we've seen beforehand, 8 factorial over 5, sorry, 8 minus 3 factorial, jumping ahead of myself, 8 factorial over 5 factorial. Okay. Now, instead of doing all that work that we just shown beforehand, especially if you're doing it by hand, instead of doing all that work, you're going to go to Desmos. You're going to go to the keyboard. From the keyboard, you're going to go to the functions key. Scroll all the way down to NPR. And then after you click NPR, it's going to show up like this. NPR equals, sorry, not equals, NPR parentheses. What you're then going to do is you're going to put inside the parentheses, like so, for this particular problem, N R, sorry, and as a general case, NR, but for this particular problem, you're going to put NPR 8, 3. You must have the comma in between. Otherwise, it will not work. Okay. If you have a TI Inspire or a TI 84, there are certain buttons for you to be able to click on that can help you get this. However, if you have to figure out whoever has that that calculator and wants to know how to do it, you can go ahead and ask me to show you. I can figure it out for you, unless you can try to figure it out. But if you can't, you can ask me. I can figure it out. So that's how we use it. And so after putting that into your calculator, you should get an answer of 336. Okay. 336 here. The next thing we're going to talk about are combinations. And combinations uses the same kind of principle as permutations, just slightly different. Okay, so if we look at this problem here, it shows us a couple things, right? It shows us the permutations of setting up these 4 letters, so A, B, C, D, and 2 letters, 2-letter, I guess, groupings or pairs you want to call them. Okay. But the thing that sets off combinations and permutations to be different is that order is not important for our combinations. So notice here, AB is both a permutation and a combination. However, the flip of it, BA, is not a combination. What combination is recognizing here is that AB, like the subject AB, is the same thing as the subject BA, although in a different order. But again, order doesn't matter here. So because order doesn't matter here, I'm not going to include BA because I already have AB. And the same thing's going to choose, or same thing's going to apply up here for every other iteration of duplicates, is what we can call them. And so what we should notice here is that we went from 12 permutations to 6 combinations. Now, I know the knee-jerk reaction is to say that 6 is half of 12, right? 6 combinations of half of 12, and that is correct. However, it is not correct for every single permutation and combination set. Okay, it is possible that we get exactly half, but it's also possible we get a fourth or a third or whatever, right? This is not always going to be true. However, what is always going to be true is that the permutations, or at least the count of permutations, is always going to be greater than the count of combinations. Always, always, always. There are going to always be more permutations than there are going to be combinations. And that's the next thing I want you to go with. Furthermore, we'll look at some combination problems. These two are, or the next two problems are the last two problems that we'll have, but they should be pretty easy because we're going to follow the same thing that we did in this problem. We're just going to make things a little bit easier for ourselves. Okay, so you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Okay, it gives us the kind of problem we're working with already. Tells us combinations. It tells us that we have a list of 8. That's the number of objects, so 8 objects. Okay, and it says we can choose 2 side dishes. Okay, and so in my classes, I said that this was kind of like the order in quotations. But I'm just going to say that 2 equals R. I think it's just easier to say 2 equals R. But for those of us that are watching it who've already seen the lesson, kind of, again, think about it as that order in quotations. Because remember, we're working with combinations and not permutations. So take the exact same approach as before, but instead of having NPR, we're going to have NCR. Okay, and this is also going to be on your reference sheets. And it's slightly different from your permutations. Okay, so if we were to replace all these values, we have 8 objects, C for combinations, and 2 for the, I guess, again, order, if you want to call it that. And our equation is going to look a little different. We have 8 factorial over 8 minus 2, and parentheses factorial times 2 factorial like this, which if it's reduced all the way down, it's going to look like 6 factorial times 2 factorial. Now, there is a button for you on Desmos. You're going to still follow the same process here. Keyboard function, scroll down to NCR, which you probably have already seen it before. NCR, and you're going to follow the exact same thing. So you're going to have our NCR parentheses 8, 2. And once you get this, you will get 28 as a result. So there are 28 different combinations that you could have those side dishes. So you could have fries and broccoli. You can then have broccoli and potato wedges. I don't know, right? All those different possibilities. Go ahead and try example 2 on your own, or example 2. Okay. Again, very similar process. It says combinations of 3 songs. 3 songs is going to be our R. And playlist N is going to be 16, or that's our number of objects. So if we're going to plug this into our calculator, right? 16C3, which in our calculator is going to look more like NCR, comma 16, or sorry, parentheses 16, comma 3, like so. And once you've done all of that, you're going to get the answer of 560. Okay. And that's pretty much it. And so we kind of look at this think, pair, share here. We've already kind of answered this. NPR is always greater than NCR. Okay, we've already kind of answered that. We know that to be true. That's pretty much it for 11.4. That's all we're going to really cover for this section. And we're going to prepare for our quiz that's coming up. And that's, again, that's pretty much it. This is the last quiz of the year. So let's make this one a good one. But other than that, let's go ahead and close things up for us today. Of course, if you have any questions, you can ask me at an appropriate time. But make sure that you are studying for this quiz. And if you have any questions, ask me at an appropriate time, and I will talk to you all later. Bye-bye.